you buy a transformer, you know that you would want it to last for 30, 40, I mean, whatever number of years is the requirement. And that was calculated based on economics, based on the operational stress. So it was well defined. But now, what is happening is the stress on the transformer is becoming unpredictable. Sometimes there may be some extreme weather event, system fault, emergency overloading, increased harmonics, as I mentioned before, or a switching event which will cause unplanned outages. Unplanned outages are very, very costly and they result in significant downtime. This is something which we are trying to avoid. In order to avoid unexpected failure, we need more reliable systems and information about the health condition of those assets, particularly transformers. And that is why we need real-time control, real-time data, and be able to do things like cooling control, fans, which operate automatically, all of those stuff to make sure that the transformers cope with all these changes. Now, as asset managers, we face a lot of challenges. I already spoke about the challenges, EV penetration. I mean, a lot of the old experienced staff members are retiring. Transformers which are old, which are very, very old. I have seen in my recent visit to Japan, I saw a transformer 1962. They're still running. The increased demand for reliability, business model disruption. This example I'm giving from a startup called Volta, which offered free EV charging in exchange for advertisement rights at very high value locations. This was never considered by the utility when they designed the area, designed the electrical asset capabilities of that area. But now things are changing, so we need to do things differently. We need to avoid risk. We no longer, it is not acceptable if we just manage risk. We have to do it at a cost where we minimize the cost rather than optimize the cost. And of course, everyone expects us to exceed performance, not just meet performance. And to do all of this, we need data, we need visibility. So the bottom line is we need sensors right from the bottom, from one transformer, from multiple transformers, from hundreds of transformers all connected together so that we can see what is going on. So ABB has been at the forefront of this development. If you look at our digital timeline, we started in 1980 when we developed the fiber optic sensors. From 1980 to 2001, we started the tech program where we introduced condition monitoring. We launched the version 2 in 2005, where we call it Tech 2.2. In 2013, we developed what we used to call as the Asset Health Center, which is today's Ellipse APM. We also had the CoreSense single gas hydrogen and moisture monitoring system released in 2015. 2017, we launched the first digital distribution transformer of the world, which is known as the TXpert DTR. Hydrogen and moisture monitoring system. We launched the CoreSense and multi-gas DGA. 2017, we launched the first digital distribution transformer of the world. I will talk about that in a bit. And in 2019, we have launched the TXpert Dry, which is the first digital distribution dry type in the world. And we have also launched AP Image, which is the advanced analytics software, which will help you to analyze what is going on inside the transformers, how much life is lost, when should I replace, when should I refurbish, all of that. I will give you some examples. And of course, our R&D team is working on machine learning, AI, which will help in maximizing your transformer performance. All of this we are doing to bring digitalization to our to all our partners. If you look at our digitalization journey, there are two things. First is the digitization, which what we are doing in this case is that we are ensuring that we have the right level of sensing and connectivity in all the transformers which ABB is offering to our customers. We are also ensuring that the equipment is remotely manageable to enable our customers some business agility necessary to optimize asset management. And on top of this, we are developing the expert services based on these capabilities, and eventually the visibility that all the sensors of all the assets in the fleet bring to our customer. So we start at the bottom, then we keep on going up. It's like a pyramid. That pyramid we call as the TXpert platform. The transformers in the TXpert platform are called as TXpert on. So we have TXpert DTR, we have TXpert dry, we have TXpert traction, and we have TXpert on power, which is the power transformer. We also have a lot of different sensors, multi-gas, DG analyzers, bushing monitoring, tap changer monitoring, and all of those are connected to the brain of the transformer, which we call as the Core Tech 4. All the sensors you see to your right are connected to the Core Tech 4, and the Core Tech 4 is like the point level brain of one individual transformer. That Core Tech 4, we then connect it to our digital enterprise APM, which is our asset performance management system, or we have the APM Edge, which is the small scale version of the digital enterprise APM. APM is specific for transformers. And what we can do in APM Edge, we can connect up to 50 transformers. So that is basically the difference between the big digital enterprise APM and APM Edge. If you have less than 50 transformers, we can connect all the 50 transformers and give you a very nice fleet analytics. If you have more than 50, we go to the digital enterprise APM where the number of assets are unlimited. You can connect as many transformers as you want. And on top of that, we have service agreements, oil analysis. We do a lot of engineering studies for our customers, testing, training, consultancy. And then we also have the world's first internal robot to do transformer internal inspection. So usually what happens is, if you need to do an internal inspection, you need to lower the oil, do a lot of different steps, send people in to figure out what's going on. So it is time consuming and also costly. So what we did, we developed a robot. Our trained service engineers then drop the robot inside the transformer tank, and it basically, and then it figures out, it tries to locate where is the fault. It takes photos, videos, all of that. So that is our entire digital transformer ecosystem, and the basic value which we are bringing to all our customers or our partners is that we are an independent and an open platform. The idea is we are manufacturer independent. We will not only digitize ABB transformers, but we will also become partners to digitize and digitalize any other manufacturer's transformers as well. We will not only use ABB sensors, but if you have other sensors, we will use those sensors to talk to our brain and do the same thing basically do the same thing. Final goal of ABB is to be your partner for asset management, condition assessment, and optimization of operations. And the main value which we bring to the table is the knowledge embedded in our software. Our software has got the expertise and footprint of our service experts. We have more than 1,200 service experts in the world, and we have more than 30 service centers worldwide. So all of that expertise is now incorporated in the software. Finally, our goal is to help our customers to predict, prevent, plan, and optimize. As I mentioned before, we want to create a value chain in the create value in the energy value chain. We connect the transformers, we create intelligence, we turn that data into actionable intelligence, and we monetize. What I mean by monetize is reduce capex, reduce risk, operation and maintenance saving, enhance reliability, optimizing transformer utilization. All of this helps you to save money, and this is what the whole purpose is. I'm pretty sure all of you are familiar with the transformer bathtub curve. We have the infant stage, we have the normal stage, and the wear out stage. Segre has done some statistics of the failure rate. 1% is assumed to be good. I mean, it's fair failure rate. So what we did, we used that 1% to do some calculations. So what you see here, we use that 1% failure rate, and within that 1% failure rate, with your existing protection devices, you can save around 30% of those, whereas 70% is not detectable. And within that 70%, 10% will result in catastrophic failure, like fire, whereas 90% are non-catastrophic. The whole idea is, if you have the data, if you have the early detection capabilities which digitalization gives you, you may end up spending $1 for repair cost for early detection, but if you let it fester for long and it becomes a non-catastrophic failure, the cost will go up by 7.5 times. And if it becomes a catastrophic failure, the cost goes up by 25 times. This is something which we are trying to bring down, because now you are able to see what is going on inside the transformer. If there's a catastrophic failure, I mean, apart from environmental damage, government penalties, I mean, damage to the reputation is very, very important. That is something which we all can save if we have the data, if we have the visibility. In my next slide, I'm showing you what happens when you put in sensors. So what it does, it basically helps you to push down your failure occurrence from the earlier 70% to almost 28% now. Simultaneously, it will help you to push up the failure prevention from the earlier 30% to almost 72% now. And when you are able to do that, this is money. I mean, this is how we monetize. I just gave you one example of how you can do cost return of investment or costing calculations for moving towards digital. This is just an example I showed you. We can do, I mean, there are a lot of other different factors which help in calculating the return of investment for moving from a conventional to a digital transform. So what is the TXpert on power digital transformer? It is the building block for your digital substation. I mean, if you want to have a digital substation, the transformer is probably one of the costliest item in that substation. And if you have a digital power transformer, which gives you solid data, I mean, it helps a lot. it has to be a modular and scalable platform so that you can keep on adding a lot of stuff to the digital power transformer. Monitoring and diagnostics definitely help in real time. It will help you to avoid unplanned outages. Higher confidence in the integrity of the equipment, because you now are getting the data back from all those sensors. Improve safety, because you can reduce human exposure to the substation environment. And fleet management is something which we all want to do. We all want to have a nice view of what is happening in our fleet. So to do that, we have introduced the world's first digital power transformer, TXpert on power. You can see the standard solution comes with an electronic temperature monitoring with top oil and winding temperature information, load information. All the measurements are recorded in this ETM, which we call the Cortec 4. Cortec 4 it allows scalability, and it also allows customization in line with what individual customer requires. So sometimes you may want to add a online DJ device, you may want to add a electronic breather. All those conventional devices which are there in today's transformers, all of them can be converted to have an electronic output which comes to this brain of the transformer, and it starts giving you real-time data. And apart from that, we can do monitoring and diagnostics, and digital solution can be upgraded or can be retrofitted if the need be. So the whole idea is that even though power transformers are engineered order, we can still standardize to have positive impacts on cost, repeatability, and after-sales support. That is something which we are trying to bring in to all our customers. If you all can see my next slide, we have 3 different offerings. We go with the standard offer, a silver package and a gold package. In the standard offer, we just introduce the Cortec 4, and we use Cortec 4 to do top oil and load measurements. And then we have all the IEEE 60076 algorithms already inbuilt into the Cortec 4. So each Cortec 4 will represent one transformer with its own particular characteristics. So when we make the transformer in the factory, we know how much oil we have used, we know how much winding materials, what is the weight of the winding material, how much paper we have used, what is the weight of the tank. All of that data is already there in the factory. All that data is now used to feed information to the Cortec 4. So the Cortec 4 becomes like the brain for each power transformer. And if you go for the next level, we add sensors. If you go for the highest level, we add a lot of other devices, protection devices, all of them talking to the Cortec 4. So my main focus today is to talk about what is the Cortec 4. The Cortec 4 is a very modular transformer monitoring system. It is designed to collect, aggregate, manage, and analyze data for one transformer. And then if you have 50 transformers, you will have 50 Cortec 4, all of them talking to APM. So Cortec 4 basically monitors top oil temperature, dissolved gases, load, cap changer monitoring, bushing monitoring, and all the other devices. And it models and stores data for hotspot temperature, aging rate, overload capability. And it also can control the cooling fans to maintain the temperatures within set limits. It's a very, very simple device. We have tried to keep it as simple as possible. And you can see cooling control. It can talk to your SCADA system, fiber. We have given fiber and Ethernet options. USB options to download data. I mean, you can connect your CTs, connect your top oil sensor, all that. The Cortex 4 we have designed to function from 100 volts to around 240 volts AC, both 450 and 60 hertz system. We have tested it from minus 40 degrees to plus 60 degrees so that it can be used all over the world for different operating humidity conditions. So the basic idea is we take the top oil temperature, we take the load data, and then we use the IEC algorithms to calculate what is the winding hotspot, what is the aging rate, what is the loss of life of the transformer. So basically, in every 24 hours, the Cortex 4 will calculate how many hours out of those 24 hours you have used. And then it will keep on adding up every single day, every year, and you will get a very nice feel of how much you have used the transformer. How it is doing that? I'm sure all of you know there are losses. Due to losses, there are heat produced, temperature goes up, and we have conduction, convection, radiation. The whole idea is to basically find the winding hotspot temp. Once you know the winding hotspot temp, we can predict what is the life lost. All of that is now part of the Cortex 4. So that algorithms, which earlier you had to do in some Excel sheet or some other program, everything is now part of the brain. So that once the transformer is there, you can immediately know what is going on. What we are trying to calculate is by using the transformer, if once you have the online DGA sensor with the moisture figures, with the temperature, we're trying to find out how long it takes to fall to 200 dP. I think all of you know that the end of life of a transformer is considered to be around 200. That is what something we are trying to calculate in the Cortex 4. And we know temperature is never constant, so we have uploaded the entire IEC thermal model. And as I mentioned before, all the transformer specific characteristics is now part of the brain. And that is how we calculate a lot of different features for all of you. This is how the dashboard looks like. So if you look here, we have the homepage. We give you the top oil temperature. We calculate the bottom oil temperature. We give you the loading. If you have a bushing monitoring system connected, we use our algorithms to see how the bushings are like. If you have the DGA connected, we give you the DGA data. We do the aging calculations. We do cooling efficiency calculations. We tell you, the Cortex 4 is able to do cooling control. This is the point solution which we are offering to all our customers at the transformer level. Then we migrate to the fleet level. So what is the Cortex 4? What are its capabilities? I'll give you an example. We have always had questions from people about, can I load my transformer at 100% and my ambient temperature is high. So with the Cortex 4, now for every single day, for every single hour, you will have the hotspot temperature calculated. If you look at this diagram, our hotspot temperature is always below the maximum acceptable temperature for the entire duration of the time. That means even though you are loading the transformer at 100%, you are well below the margin and your accelerated aging factor is acceptable. So the question, can I load my transformer to 100%, is answered. You now do not need to ask anyone. The transformer itself is telling you, yes, you can. If you look at this example, it is now going up to 1.2 pu. And in some duration, I mean, you can see the hotspot temperature is above your 110 degrees for a certain period of the time. And when that happens, your aging acceleration factor jumps from 1 to 5 when the hotspot is above the limit. This is something which we don't want. So now, when this happens, we can immediately use the Cortex Force cooling control function to start the fan so that we can keep the hotspot close to the limit all the time. And then with intelligent loading, the acceleration factor is acceptable to us. So this is something which the Cortex 4 will provide that data to the asset manager to make informed decisions. So this is one of the use case of Cortex 4. Another use case which I would like to present is that an aluminum smelter hired us to supply a solution to increase the capacity of their installation by 15%. And they wanted to retrofit their existing transformers and get a payback period of 3 years. So what we did, we first went and did a feasibility study based on the condition of the transformer and risk associated with the equipment. Some minor repairs were needed, and then we decided we will install the Cortex 4 and the DGA device. The customer also asked us to provide remote support and quarterly reports. So with that solution, the customer was able to increase his production for almost 4 years by 18%, with no loss of production and almost negligible investment. Just by monitoring, he was able to do that, rather than purchase a big new transformer. And anyways, the payback was less than 3 years. So it made great sense for him. I will again also present a use case where we had an offshore wind farm that ordered a transformer with a load profile which almost represented around 70% of peak production rating. I mean, even if you see to your left, most of the production happens when the transformer is around less than 60% of the load. But then, when the wind picks up, the transformer is overloaded. This overloading increases the hotspot temperature, which in turn increases the aging acceleration factor. So with this data, the customer was now having solid information on what is happening to the transformer. How long the transformer is aging fast, when it is aging lower than the normal aging rate of 1, if it is going above, below, how much life it has lost. So the customer had real-time data with which he can make solid decisions. That was another use case which I just presented. So the TXpert on power transformer, what it does for you, it gives you plug and play capabilities. You can put in a lot of sensors, gas analyzers, other safety devices, and then you can use it as a point solution which monitors times, it models and stores data, it runs algorithms, it controls your cooling fans. Then you can connect it to your station control room, and in the station control room, you can download your device locally or you can upload it to the cloud. And then you can have multiple digital power transformers connected to the station room where we can do cloud computing and analytics. This is something which the TXpert power transformer combined with ABB's expertise enables you to do. I will now move on to the next level, which is the TXpert enabled APM 8 software, which will complete the digitalization journey. I mean, within the ABB power grids, our digitalization journey is very, very simple. We start at the bottom, we start at the transformer where we are ensuring that we have the right level of sensing, and then we can connect Once we are able to connect, we are ensuring that the transformer is manageable, remotely manageable, which helps customers to bring business agility. And then on top of it, we have developed the expert services based on these capabilities, and eventually to give the visibility which is obtained from the sensors. And that's how you are better able to manage your fleet. So what is the APM Edge doing? Once you connect, once you collect, you are sending the data to the software. We have done a lot of statistical modeling and a lot of other algorithms inside the software. And once the software does its calculation, we inform the customer what needs to be done. We tell them when you need to do it. We give you maintenance scores. We give you replacement scores. We give you the risk associated with operating the transformer. And it's basically like a closed loop. So once you start sending the data, we analyze, we inform, we ask you to do something, you send the data back to the, you take some actions, you report it back to the software, and it's a continuous cycle. The whole idea is we are now moving from time-based to condition-based management. So from time to condition to reliability-centered management. Earlier, time-based, I mean, everyone knows what is time-based. We plan according to time intervals, and we do maintenance sometimes even if it is not required. Then we move to condition-based, where we plan our maintenance based on the actual measured condition of the component. What is the cruciality? What is the impact of failure? All of these are not considered during the planning. Now we are moving towards reliability-centered maintenance. The whole idea is we plan according to the risk profile of the critical component. We determine the component health and its impact on the transformer. Based on that, we act. APM Edge is the number one asset performance management for utilities. I'm showing you a leaderboard from Navigant Research, where they showed that ABB's APM solution is number one. Why? Because we have over 100 years of OEM transformer manufacturing knowledge. We have the largest dedicated transformer service organization in the world. We have done more than 10,000 transformer assessments. And all of that is part of the ABB's MTMP program, which is now part of the APM Edge. We are trying to listen to solve your problems. I mean, we get questions such as, I want to identify my data trends to reduce my maintenance activities. I want to understand what happens when we overload our transformers. I want expert suggestions. I want to compare multiple transformers. I mean, a lot of these questions we always get, and the idea is we use the software which will help the transformer experts to do fleet assessment. The whole idea is, with a lot of data coming in, I mean, the transformer experts will be overwhelmed with so much data coming in from so many different sources. So the software is just like a helper to the transformer expert to do some data cleaning, to do some data filtering, all of that which is done by statistical models which we have implemented in the software. So what is APM Edge? It is the most cost-effective entry to the industry. I mean, it's very, very simple. You can see the risk matrix. You can see the risk trend. We need a lot of data. APM is very, very data hungry. I will show you what do I mean by that. Very, very flexible communication. We can go from directly from the core tech and the core sense, our field level devices, straight into the software, or we can go via Wi-Fi, or we can go to the cloud. So, I mean, comms is something which the customer decides, and we have almost all the available protocols to be able to do this. What APM will bring to you is fleet level analytics, DG analysis, offline, online. For online, we take care of 13 different manufacturers apart from ABB. We have algorithms developed for each and every one of those 13 different manufacturers. You can have ABB's Core Sense, you can have Transfix, Callisto, Hydran. We have algorithms for each one of that. Then we also do thermal analysis. We do a lot of different parameter analysis, power factors, bushing power factor, capacitance, standard oil test. And once we have all those data, we calculate the probability of failure and we determine what is the risk of the transformer. And then based on that, the software gives you expert recommendations. These expert recommendations are based on the field assessments done by more than 1,200 ABB engineers all over the world for more than 10,000 transformers. So they have done the condition assessment, they have given reports, all their expertise is now part of the software. So what is the software doing? It needs data. There are some mandatory data, nameplate, factory test report, drawing data, all of that. If you have online DGA sensors, we put in the DGA sensors, and then inspection data like the DGA test results, visual inspection results. I mean, no other software will ask you if you have corrosion in your tank, what is the risk of failure to my transformer? So we have taken care of paint flaking, corrosion, bushing, dirty bushing, crack shed, all of those things we have taken care of. Small, minute things which can help in the transformer failure. And for us, everything is important. Whether it's bad DGA or good DGA is equally important for the foundation of the transformer. If the foundation is not correct, if there is tilting, we have given importance to everything. We have not prioritized. Everything is important. Everything contributes to transformer failure, and that is how we have developed our algorithm. So I'll give you a quick example of DGA interpretation. So we had a transformer where we got offline DGA data, and then we got the lab test results. And what we did is we checked against the normal IEEE limits. The lab results gave us this answer saying that we have a problem. The DGS indicate there is a thermal fault, and all it did was recommend further monitoring to establish trend and resample in 6 months' time. So we used that data, and we told the customer that let us put this data in the software, and then we will tell you what if our recommendation is different from that of the lab. So the first thing what happened is we took 5 data sets from 2016, 17, 18, and 19, and then we uploaded it in the software. And you can see the ethane gas levels has gone up considerably. Once we put in this data, what the software automatically said is that this ethane gas is a statistical outlier because we are seeing almost 447% increase from the previous level. And the expert system straight away recommended that it may be a mistake in the input data, it may be something to do with the sample contamination, and it recommended please double check. that recommendation we passed on to the customer and said, please double check, please redo your offline DGA. And they came back and said, okay, they did the test in 2019, and this confirmed that the gas is actually going up and the result is not an outlier. We re-uploaded the confirmation sample, and what the software recommended is that yes, it is actually above 50% of the IEC gas levels, and based on the full 5 offline DGA samples, we are showing an increasing rate of 60 ppm per year. And it also said that if this trend is maintained, within 1 month's time, you will cross the 100% IEC concentration level. And the expert system, what it says is that the hot metal gases are there. Fault temperature is calculated around 150 degrees. You need to check your core bolts, contact resistance. You need to do some tests. So the expert system clearly identified that it is the gas is coming from localized overheating, and it also calculated the risk associated with that particular cause. And it said the risk is low for that particular DGA result. But the rate of rise was on the higher side of 60 ppm per year, which was based on linear trending of the 5 manual datasets. So based on that, we knew that we need to monitor. So we put in an online DGA monitor to verify whether what the software said of IEC ethane gas levels going up within 1 month's time is correct or not. And we installed the online DGA device. And what you see here, I took the data from the online DGA device and I did a linear fit of the values. And you can see from September 2019, I crossed 200 in mid of October. So what the software predicted that in 1 month's time you will cross, actually crossed. So that was that is how we were able to do trending of the DGA offline DGA samples, and based on that we told the customer that you will cross around 250 ppm in June, not in June, in May 2020. We were, and then the shutdown was planned in June to investigate based on what APM recommended. So I mean, once the lockdown in Singapore is over, I will try to find out whether the customer will shut down the transformer or not. But we were able to tell the customer in September that in 1 month's time you will cross this, in 6 months' time you will cross this, so you better plan your maintenance at this point of time. And we also told him these are the things which you need to look for inside the transformer. This is the power of the software. So if I show you my next slide, you can see the 2 differences. Whereas the lab said, okay, there is trouble, please resample in 6 months' time. Whereas we said in 6 months' time, we need to shut down because this is the gas which is going up, risk is low, it is coming from overheating in oil, ethane will reach more than 100% in less than a month. This is the rate of rise. These are the sources of local heating. Please do winding resistance, insulation resistance. We told the customer what he needs to do. That is the power behind the expert system and the software when you compare it against the lab. Similarly, there is another scenario which I would like to discuss is visual inspection. So this is a hypothetical scenario which I have created where I have said, okay, I have a new bushing installed, everything is fine, but in every 6 months' time, I have certain problems like dirty shed, crack shed, gauge leak, oil level low. Then I do a thermal hotspot and say, okay, I can see high temperature, oil has gone bad, DGA status has gone bad. And what happens? when I upload this data to the software. The software automatically says, when you start in 2013, everything is fine, your risk is low, you are in the green zone. Once you start uploading the data, you can see the risk trend to your right. The risk has jumped, has increased from 0.2% to 2.25%. And it has shifted from green to yellow zone. That means now you are in the medium risk category. If we compare it with the traditional 1% failure rate, we are moving towards the traditional 1% failure rate. So what we have done in AP Image, instead of linear method, we have used non-linear method to do the calculation. And we have made the system much more sensitive to each and every individual component in the transformer. I will give you a quick example on how does it compare to the traditional health index. We are all very familiar with the traditional health index computation. I'm sure you must have seen this calculation method where we take around 24 different conditions of the transformer. We assign scores based on what we see or what we think should be the score. If you put in 0 for the bushing and 4, which is the highest score for everything else, you will see that the traditional health index method is giving you a score of 96.88, which means the transformer is fantastic. I mean, 96.97 score condition is very good. We expect transformers to last for more than 15 years, which is not the case because the bushing will take the transformer down. That is how we have increased the sensitivity of the traditional health index method in our software. So we have all the standards which are built into the expert model, whether it's IEEE, IEEE, or SIGRE. We have DGA samples. We have lots and lots of DGA samples based on where we have developed all our algorithms. The software takes around 300 different data parameters. We calculate the probability of failure of each and every single transformer component and then aggregate it to give you a transformer failure component based on all those subsystems. This is based on the ABB's MTMP program, which we have done for many years. We have done condition assessment for more than 10,000 transformers only in North America, USA, and Canada. So far, we have 14 algorithms. These algorithms consist of moisture analysis, oil test, DGA, bushing, thermal profiling, furans, and we are in the process of incorporating many more. Finally, for full-scale implementation, we need data, which is named. We can start with the nameplate. We can start with the basic DGA data. But if you start give this model more and more data, the whole digital transformer ecosystem will start giving you much better results. So you can see we do a lot of different algorithms: DGA, furan, GIC, thermal, particle count, PD, bushing analysis, OLT analysis, cooling analysis, and based on that, we give you what is the risk of failure of the transformer. We tell you what is the remaining useful life of the paper, what is the replacement priority, replacement score. We give you analytics on a fleet of similar transformers, which transformer is having high risk, whether it is having a high replacement score, or whether it should be maintained. All of that is done in the software. And the whole idea is to give you a complete fleet-wide assessment of your entire transformer fleet. And for that, we need to start at the base, which is the transformers with the core tech. We equip all the transformers with such devices. Then we connect, and then we do a fleet-wide risk of failure assessment. Thank you, Noor. I am done.
Okay, thank you so much, Dr. Das, for very insightful sharing and for part his knowledge and experience and share with us a little bit a thing or two about digitalization of transformer done by ABB, which lies in the heart of the Core Tech 4 as well as collaboration with AP Image for human interface. Now, let's go through some Q&A that we have with regards to your presentations. All right,
So
are you ready?
should I stop sharing my slide?
You can maintain sharing your slides.
Okay. Okay.
Okay, I'm gonna read the question to you. Okay, give me a while. All right, the first question. What about the cost of converting an existing power transformer into a digital one, roughly?
Cost.
Yeah, cost of converting.
For costing, you have to talk to our sales team because they are the ones who can give you the cost. I am not from the sales team, so I will not be able to answer that. Sorry.
Okay, pretty much on the same.
But it's very, very. I mean, the Core Tech 4 by itself is very, very minimally priced.
Yeah, I guess that depends on the package of either silver and gold.
Yes.
And yeah.
Yes.
Pretty much the cost of converting the transformer, is it dependent on MVA rating or kilovolt rating?
Sorry, I did not get the question.
The cost of converting the power transformer to digital, is it depend on MVA rating or kilovolt ratings?
No, it doesn't depend on anything. You can convert any. It's independent of kVA or, I mean, MVA, nothing. I mean, the Core Tech is made for each and every type of transformers. It doesn't matter whether you put it in a 10 MVA, 50 MVA, or 100 MVA. The cost of Core Tech remains the same. I mean, if you have bigger transformers, the delta becomes smaller. If you have smaller MVA transformer, the delta is higher. That's it. But you can do it for any transformer.
All right.
I mean, and that is the idea, that you digitalize all your transformers.
Okay. And then there's the cost on cost. I think that has to go through sales teams. Okay, there's another question from Mr. Somil Joshi from India. He just want to know whether why are we not adding any partial discharge diagnostic tools such as UHF, bushing PD sensors or HSCT within the current software?
It is part of it.
It is part of it.
Yes, I mean the Core Tech 4 can take bushing monitoring system. It can take PD monitoring system. Yes, it is part of it. I have just not gone into that part, but it is part of it.
All right. Okay, another question from Mr. Jose. How much is the maintenance cost reduced percentage-wise if it changes to digitizations in a transformer?
Yes, we have done the complete ROI calculations for that one. And we can share, I mean, if you share the email, I can go into details with how much savings you can do. I mean, we have the maths already available.
All right, I will take note. Question from Mr. Jose. Another question from Mr. Igat. Could you please compare the DGA accuracy between ABB online DGA and gas chromatograph method used in lab?
Yes, we have done it. We have published an article on how we have done it, where we have done it. I can share that article. It details everything on that one.
All right.
And we are
another
within,
question.
We are within what IEEE allows us on the field. We are very, very accurate in the lab, and in the field, we are within IEEE. So I'm very happy with what our DGA gives you. I will share the article.
Okay, this is basically comparable with the traditional method. Okay, another question. What better? Okay.
Yes.
Another question. What is the hotspot temperature limit set in Core Tech for normal aging of transformer?
It depends. Depends on the paper and the oil used. So for thermally upgraded paper and mineral oil, we set it to 110. But it is the customer's choice. If the customer wants to lower it, he can lower it. It's programmable.
All right. Okay, another questions. how do you estimate the exact conditions of solid insulation?
So we calculate. We calculate based on the Furan algorithm, based on the loading algorithm, and we calculate a DP value, and then we also have an error margin on the DP value. We have an IEEE paper which we have published. I can share that IEEE paper with you, where we have detailed all the algorithms based on Furan, how we estimate the DP value of the paper.
Okay, another questions. The partial discharge measured from windings of transformer or bushings?
Bushing.
Okay, it's from bushings. Another question from Soumya Joshi again. Can I have put two system for main tank and OLTC for bigger transformers? Because OLTC have bigger DGA data. He just wonder whether can he put two system for main tank and another one is for OLTC for bigger transformer.
We have already done that. In Singapore, we have already put in two systems for the OLTC and for the main tank. I mean, yes, you can. I mean, it's up to the user.
All right.
That has already been done. Yes.
Okay, that has been done in Singapore. Another question from IR Jaganes Supan. As far as ABB concerned, how many transformers have been digitalized worldwide?
Oh, that I have to check with our world global sales team. Yes, I do not have the exact number. I can tell you how many we are doing in Singapore, how many we are doing in. I went in Malaysia. In Malaysia, I forgot. I have to check with my team. I can come back to you on that one because those are sales related questions. So yeah, I will come back to you on that one.
Okay. The question from Mr. Igat. In case of RIP bushing, is it need any monitoring?
Yes. And in the software, we have the option for all the three types. I have to go and dig deep in AP Image what kind of parameters we need for each of the different types. But yes, I can give you the details once I look into the software.
All right. Then the question, can I put one system for OLTC and main tank? That means one system combined and getting the same DGA accuracy.
Don't think so because the gas levels will be different. I mean, you can put two different systems. That is what I have personally done in Singapore. We have put two different DGA systems for the main tank and the OLTC. But I mean, if you put one system for the two and there may be cross contamination and all of that, and I think that is not recommended. But I have, yeah, I mean, I will check on that one. I have not done it myself.
Okay, all right. Another question from Rahimpour. Can the winding partial discharge be embedded into the monitoring system?
This is something which I will have to ask the R&D team because it has not been done yet. And I will find out whether the R&D team is working on that one or not. I will come back to you on that one.
Okay, question from Mr. Sabhi. I have experience on big difference data on DGA compare with gas chromatographic technologies. Any advice, Doctor?
Yes, I mean, there is this secret document which tells you how to do the comparison. The comparison is not straightforward. The comparison is not that you get the DGA data from the online monitoring device and the lab and you straight do a comparison. There is a whole set of process which you need to follow. You need to take 4 samples, you need to take an average, you need to know the accuracy of the lab, you need to do the DGA within 1 or 2 days. You need to set the temperature of the lab, I mean the DGA ppm results at 20 degrees and 0 bar, and the same thing you need to set in your online DGA device. I mean, there is a big, I mean, maybe 10-step procedure before you can come to that conclusion. So I hope you go through the SIGRE device and you can do the comparison. That will give you much more accurate results.
All right. Another question, does the Cortex 4 able to monitor the wear and tear of OLTC contacts?
We have the contact wear model, yes. We have developed the model for ABB OLTC. So that algorithm is included in the software.
Okay, another question from Mr. Imad. Recent studies done by Segre on scrap transformer concluded that DP estimation based on Furan analysis can over or underestimate the DP. Don't you think there is a risk of inaccurate decision?
Absolutely. That is why I will point you to our IEEE paper where we have done a plus minus percentage of that prediction. So if we will not say you that DP is 200, we will say you DP plus minus plus this minus this. So then it will give you an estimation. So that particular thing is already part of our software.
Okay. Another question. If transformer not having FOS, can we take WTI reading for winding temperature for overloading purpose? Cortex will take inputs from WTI for analysis. Is it possible?
We are doing it for the OTI, and based on the OTI, we calculate the winding temperature. We use the OTI data to calculate winding and then calculate the hotspot.
All right.
But
another question from
if you have the if you want to put the WTI data, it is possible. Yes.
Okay. Question from Mr. Igat. Is ABB online DJA need consumable materials such as calibration gas?
No. It is maintenance free. No consumable materials. No, nothing.
Okay. Question from Dell. Natural ester oil can be used for insulation practically in large transformer?
Yes, people are now pushing for it. Yes. ABB is also pushing. Depending on the customer requirements, we are also we have our experts who are recommending that. Yes.
Okay. Then another question from Mr. Sirut on the Cortex difference. What is the difference between Cortex 2 and Cortex 4? Is Cortex 2 can be upgraded to Cortex 4 without replacing the hardware?
No, Cortex 2 and Cortex 2.2 were custom built for each customer. The idea was whatever the customer needed, we built it from scratch in Cortex 2. Cortex 4 is like an off-the-shelf device. We will put it in each and every transformer, our transformer that we produce. So the difference is you cannot upgrade, but we can replace.
Okay. We're still welcoming any further questions from participants, but in the meantime, as we are waiting for more questions from participants, I would like to seek your assistance to provide some feedback of today's session. So I will share this QR code. Please scan this QR code and provide some feedback on today's sessions. Okay. As we continue, I will also urge for you to share, is there any further questions that you have with regards to the session today?
And I will be very happy to, answer offline as well.
Okay, there's another question, Mr. Dr. Das. How accurately partial discharge can be measured on bushings?
Oh, that is very, very subjective. I will take it offline. How accurate? I will have to take it offline because there are many things which tend to influence the result. So this is not something which can be said in terms of X percentage, Y percentage. We need to go deep a bit, yes.
All right. Another question. What is the estimated timeline for installation of these sensors? Do we need outages?
If you are only talking about the online DGA devices, then you do not need outages. If you want to retrofit the Cortex, then yes. But if you specify the device coming from the factory, then everything will be pre-wired and ready to go. So it depends. It basically depends. For online DGA, no.
All right. Questions on 10 delta test.
Yes.
How about the 10 delta test? Is it embedded as part of the Cortex?
Yes.
Okay. To all participants, should you have any further questions, please feel free to jot it down, or you can write an email to Dr. Das. I will share with all participants Dr. Das' emails right after the session. Is that okay, Dr. Das?
Yes, absolutely fine.
All right. Ladies and gentlemen, I guess we have come to the end to our webinar session today. We really appreciate your presence and participations in today's sessions. Hopefully you have gained some insights of what you intend to learn today. So before you leave, don't forget to scan this QR code and do provide some feedback for our improvement in the future sessions. All right. Until then, I think thank you so much, Dr. Das, for sharing your experience and knowledge with us all. And thank you so much. Thank you so much to Dr. Haroon as well for sharing some insights on IEEE PES. And thank you so much to all participants for attending. Okay, then you take care and have a nice day.
Thank you, everyone.
Thank you, everyone.
Bye-bye.